What's up, statisticians? I wish that I could rap, and the reason is because one of the scenarios we're going to be doing today are people that listen to rap music. I've never listened to it. I don't know if rap Christian music counts, but I wanted to remind ourselves, before we get into that problem, rather, I wanted to remind ourselves of what we discussed before. So here we're talking about, we are going to looking at characteristics of a two-sample test. We have to have two populations and they must be independent. We still got to look at the idea of normality. Here we're going to be discussing in the example the equation for the standard deviation. Remember how we came up with that? We looked at it for one sample and we're saying, okay, I've got two populations instead of one. Okay, so it makes sense not to just have this one, to have it basically twice, double vision. Okay, we know our conditions and assumptions here basically restate themselves. We got our SIN, our random selection, 10% rule, normality. Here I mentioned the conditions and assumptions, but I misstated. I should have said that here I'm just looking at my socks without the outliers, in which here the normality is the same as the shape, because if it's the shape is approximately symmetric, it's normal. Then here we talked about the generic equation for the two sample Z interval, but now we get down to the meat, and this is where we're going to be working in a few minutes. Here is the ugly formula for the two sample Z interval. Now that I went through that review in a minute and 40 seconds, go ahead and take a moment to read over this. And the first thing we want to know is, what is the shape? So in other words, we're looking for your normality. So as we can see that the shape of this distribution, which is the difference between the two populations, the two samples of the two sample proportions, the two sample proportions, not population. It's approximately normal because here of the large count condition. Remember, we've got to check it for not just one, we've got to check it for both. And because this is true, okay, all of them being above, being greater than 10, that means it's approximately normal. So the shape here, you can say it's symmetric, you can say it's approximately normal. Next, as we look at the idea of what is the mean of the sampling distribution, remember the mean is nothing but, as I cover this up, your P sub 1 minus your P sub 2. I'm sorry, now we can see it. So with that being said, here you just do the math because you've got the proportion of one and the proportion of the other. Remember, that was derived from the following. The 35% that they have here and the 25% that they have here and the 35% that they have there. Okay? Now, I don't know if you can tell, because you really can't. That should be a 2. The next question is, find the standard deviation. Okay, we're going to show all of our work. Remember, the standard deviation was that ugly formula. Go to page 1 of your notes. So this formula right here. Now let's write down that formula and then plug in the information. So please notice here, this is of the population because it's the sigma. Here's the formula. That's why there are no hats anywhere. Okay, and then you just take it and you plug it in. Here is for the first bag and the probability of not getting red in the first bag. Okay, here is the probability of getting red in the second bag, crackers in the second bag. Here's the probability. And please notice, the first bag, there were 50 crackers in bag 1. And in the separate bag 2, here is the 40. So we just take that, and unfortunately, you're not going to like this, but for you math geeks, here's your math, people. Here's your math. So take it, crank it. That's what you get. Now, let's proceed to number 6. Go ahead and read it. And please notice the directions. Explain why the conditions for constructing a two-sample Z interval, P sub 1 minus P sub 2, so the proportion of one population minus the proportion of the second population, are not met. Okay, now that you've read it, the large count condition is not met. And the reason the large count condition is not met is, notice, here we have the group of 53, and the probability of the wrist injury while wearing the band was 6 out of the 53. So it is not greater than 10, so that is why it does not meet it. And notice what I said here. If one of the 4 don't work, that's all it takes. We don't have to sit there and show the other 3 that do. All we have to be concerned about is that all it took was one that didn't work, so therefore the rest don't. It's like dominoes. If one falls and is connected to the others, they all go down. Okay, next, let's look at this right here. We are going to be doing a confidence interval in a few minutes. So let's just take a note of how I'm going to do this. Please take a moment to write that down. And very shortly, we are going to be doing a problem with this, but that's much better. I'm so sorry that the light wasn't there before. Okay, so as I just slide over here, clear. So I go to Stat. Go over to Test. Trying to get better lighting. There I go. Okay, go down to until you find two proportion Z interval, which is for my 83, it's the letter B. I don't know what it is for the others. And then as we look at this, notice all the stuff that you've got. You've got your, you need your success for the same for the first group over the total number of trials, success for your second group over the total number of trials, and your confidence interval. So like I said, you just enter the data. Now before we do that problem, and it's going to take us a little time, I want to kind of proceed with our notes. Okay, please take a moment to read it. I'm now on page 4 of your notes. So here we're talking about broken crackers in the package. One idea is to microwave for 30 seconds. What is the question here? The question, I believe, is the same question. Why have the conditions and assumptions been met to proceed with the interval? And the answer again is no, because LCC, large count condition, has not been met. Because as you can see what I have underlined right there, they said that newly baked crackers to the microwave, after 1 day, none of the microwave cracker groups showed any hairline cracks. So that means your LCC was not met. And like I said before, if it fails for one of the 4 or a portion of the 2 groups, which was 2 times 2 is 4, we don't care that it fails for the other. So don't waste your time. Now let's continue on to problem number 10. Problem number 10 is asking us, okay, that's why I said I wanted to know if I could rap. No, I can't. Okay, I know I suck. Sorry. I'm terrible. Okay, so go ahead and read number 10 and be ready to do it. Okay, so after you've read this, you can see that we have a survey was taken looking at 634 blacks between the ages of 15 and 25, that's your age, and then whites 567, They were randomly selected in both cases. And then it found that 368 of the blacks and 130 of the whites listen to rap music every day. So they want us to, number one, calculate the standard error. Okay, now what is that formula? So here, our formula for the standard error, remember, first of all, let's make note of information that we have highlighted, but it'll be a little easier for us to do the work if I have it written already. So notice that instead of using 1 and 2, I'm using B and W for black and white. So here's the total number of black, and here is the proportion of blacks within that age group that listen to rap music daily. And here is the number of whites, again in that age group, and here's the proportion of whites that listen to rap music daily. So that's just the prerequisite stuff. Now, let's do the standard error that they're talking about. Remember our formula. Now, let's notice why this looks a little different than the other. The reason it looks a little different is because, remember, this here is the standard error of and this is all about the sample. Before, when I asked you for the standard deviation, it was about the population. So you tell me, as I'm looking at my work, what am I missing? I'm missing my hats. And then let me change this 2 to make that a B and make that a W. So I've got these values that came from here and here, and I'm just going to take them and I'm going to plug them in. And if your question is, Ms. Yarbrough, is there an easier way of doing this? Not if I just ask you for standard error. Okay, I just kind of fibbed. It's kind of dependent on other information that I have, but based on what I have right now, no, it's not. So you just take it and crank it, and this is time consuming, so if you just want to take the time to not worry about putting it in your calculator, just, write it down and trust my math, and here is your answer that you get, the 0.0264. So that's part B. Then they asked us to interpret it. So remember, all we're doing is interpreting the standard error. So this is how I interpreted it. Let me try to get a better picture here. So given the random samples of 634 young blacks and 567 young whites, the sample proportion difference of these groups who listen to rap music every day will vary 0.0264 from the true difference. If you look at your book states it's slightly different. But you can look at your book if you want to get a chance to see how they, because theirs are more words. It's like, no, that's too much. Okay? But remember, we're talking about how much it's going to, a standard error is basically how much it's going to, how much it's going to move, or what the difference is from the true mean. Because remember, what is that formula for the confidence interval? It's plus or minus. Okay, now next we're going to be doing letter B. And letter B, as you slide up here, is asking us to construct the confidence interval. You're going to need a lot of room for this, so get ready. Okay, so what I'm about to do, it took me an entire page. And I didn't have much room left, so I mean the entire page. So remember, we have our 4 steps: our statement, our conditions and assumptions, our math, our calculations rather, and our conclusions. So our first statement, that this is a 2 proportion Z interval, and I've got to mention my CI as 95. I don't have to mention it there. I could mention it somewhere else, but I noticed as I was doing it, I had not mentioned it, so I decided to write that up there later. Okay, let's look at what our, how do we define it? Well, P sub 1 is a true proportion of young blacks who listen to rap music daily. That's daily, that you can't see it. And then here, and yes, you can do this, P sub 2, and actually, didn't I make it a B and a W? So let me change this to B and W. That is the number, the true proportion of young whites who listen to rap music daily. Okay? Now remember, this is not a hypothesis test, so there's no HO and HA in here. This is just a confidence interval. So next we are on to our conditions and assumptions. Okay, so here's the part of our sin. We are, now first of all, that sample survey, I wrote that down first, but you don't have to have that. You can just have, it's two randomly chosen independent groups. And yes, I do want them to say independent, because if they're dependent, we have to use a completely different interval, which takes you to stats 2, by the way. Okay, next here, for independence, the 10% rule. Remember, we're looking at our population of all blacks and all white of that age group are going to be 10 times, it's going to be greater than 10 times the sample that you got. So here's my math. Okay, next, here for your normality. You know you're using the large count condition. So you can do this in one of two ways. Here, you can state all of the successes and failures times their sample are going to be greater than or equal to 10. But the one problem with this is that you still have to have some numbers in here. And I'm actually going to find the book really quickly and show you what the book did. Okay, but I'm going to continue with this. Here, doing it the old school way. And as you are writing that down, I am going to pause to find what the book did, because you might like that. Okay, so as you look at this, this is what they said, the number of successes and failures. So basically what I said, but then remember I said we have to add some numbers, so they added the numbers of the young blacks and the success and the failure of the young blacks and the success and the failure of the young whites. So instead of showing the inequality in the math, they did it this way, and honestly I kind of like it. It's less work that's written, because it's still the same, because you had to do the math to be able to come up with that in the first place. Okay, now that we have our large count condition, we have met all our conditions and assumptions. Now we have to we can now proceed with our test. Okay, now let's continue. We can proceed like I said, or I don't know if I said it or not, I paused. Okay, so here's my equation. It's ugly. Remember though, you've got your hats all over the place, because this is about the sample. Confidence interval is always about the what? About the sample. So we have this, and here we're taking all of those values that we mentioned and plug them into the formula. The curse is that no, you cannot just you have to plug it in, but you can kind of work around that. Meaning, if I already have the proportion of the sample for the blacks, proportion of the samples for the white, I have it defined up here. I've already got my NB defined somewhere. If not, I could easily put it down. Okay, and all I've got to do is mention the Z star. So the reality is, if I have this information right here that I'm about to highlight, and this is over tape, so it probably won't work. If I've got this, I'm going to put an N in there in a few minutes, the N and the B, and then my Z star. If I have all of those, I will be fine. I can just jump from here to come up with my solutions. So I'll say what I said again. If you have all of this information, you've got every component of this right here. So you can jump from here to what my final answer is, which takes me to, how do we do that, Yarbrough, without having to do it by hand? Well, I'm glad you asked that, because you know there's a way. Okay, so pull out your handy dandy calculator, and remember what I showed you guys earlier? So let's do it. Okay, so let me clear out of this. Clean. Okay, quit. Okay, so I go to stat, go over to test, go down to which letter? Yep, B. Okay, now what information that I had my, I needed to know, how did I get that 0.580? So let's put something else next to this right here so we can show where we got that information from. Okay, so this is where these values came from, and we need that for this right now. So for the blacks, it's 368. That's success. Total number of trials, 634. Okay, for the whites, 130. That's your success. Total number of trials, 567. A 95% confidence interval. Then let's press calc. Here, notice what happens. We already knew this. It's no different than the one proportion in terms of the output, but now we've just got two of them. And for this reason, since I show a 1 and a 2, you might want to stick to 1 and 2 instead of using the letters B and W, but you do what you want to do. So here's your 0.580. Here's your 0.229. Here confirming your sample size. And up here is your confidence interval. So here is here's my math right there. And there's my confidence interval. If your question is, Yarborough, do we have to show that? The answer is no. I was just showing you how it's by hand. So far we've done our statement, our conditions and assumptions, we've done our calculations. Now we're going to do the conclusion. We are blank % confident, and there you go. And if you notice, it's no different than it was before, except now we've got true proportions difference. I was in automatic mode and put the word mean, and I crossed it out. And I could have used my whiteout strip, because that thing is my friend, because I go through a lot of them. But I wanted to show you that that was wrong, so that's why I decided to keep it there. Okay? So we are 95% confident that the true proportion difference lies within the interval of da-da-da-da-da. And, I know I would mark this wrong. So we've got to put this in context because this is too generic. So as I clean this up, we're 95% confident that the true proportion difference of young black and whites who listen to rap music every day lie within the interval of, okay. So there we go. A lot of stuff. Have fun. And I will see you tomorrow, maybe. Bye-bye.